Hello, and thank you for tuning in to the Flatirons Syndicate Motorsports Podcast. This show is brought to you by Flatirons Tuning, your source for any aftermarket or OEM Subaru parts. Be sure to check out our store at flatirons.tuning.com and stay tuned with Flatirons Tuning. Welcome back, everybody, to the Flatirons Syndicate Podcast. We are here today with another special guest. We have got Mr. Ryan Payne from P2P Racing joining us today. And Ryan, I think just as a good place to start, let's talk about the origin of P2P Racing. How did that come to be, and
Yeah.
what do you guys do?
Yeah. So I can drone on for this for a long time. So if
Okay,
I go on too long, just, let me
I'll
know
I'll
and I'll.
I'll start waving at you or something. Okay,
Yeah. So I started with Subarus back in like 2004, 2005. I was 17, 18 years old, too young or too poor and young to own one, but loved them nonetheless. And bought my first one in about 2010 and started tracking it 2012, 13, 14. And so that entire time, you'd blow an engine every other weekend kind of thing, and you'd put one back together and keep going.
yeah,
And those are the early days of tracking a Subaru. And,
sure,
early on, we didn't really have a company that we were working with that we felt was doing a really great job. So we started doing engine builds for racers specifically. We started the LLC early on and just kind of just doing a few a year just to kind of help offset costs and with racing. And yeah, it just snowballed from there. We started working with shops directly. We started working. We're in Texas. We
okay.
build obviously Subaru engines, um, and yeah, we work with you guys out of Dallas, Fort Worth, out of Houston, mostly race car stuff. But I started selling to the public and general staged builds.
Okay. So it kind of you started building engines, and that's kind of like just doing assembly, and then it kind of just branched out from there.
That's right. Yeah. So we started. I bought a mill and all the equipment, and we were just doing things in house. And again, local guys. And we found some things out on the Subaru side on how to machine them. So I'm an engineer by trade.
Okay.
It was my day job for 15 years. And I did mechanical engineering and rotating equipment, and specialized in pumps and motors. And so we were able to apply some of the GD&T and some of the knowledge of manufacturing to Subarus, and we found some secret sauce, and it's
Okay.
been working really well for us.
So you basically have an engineering background, which is, I mean, tangentially related, but you're a Subaru enthusiast, and then you found a way to kind of take your engineering and apply it to this platform that you were driving and having fun with, and found some things that worked.
That's right. I went one time around the track and I was hooked. There was no going back for me.
That happens. That happens for sure.
Yeah.
Okay. And so at this point, let's talk about P2P racing and just kind of like a top level, what do you guys do? Obviously engine builds, but I think there's a little bit more going on than just that.
Yeah, so I mean, we've got our staged blocks that we do, but we specialize in tailoring a block to a build.
Mm,
So if you've got a project, we've got a bunch of projects this year, but if you've got a project that requires some special considerations, we can do that. But we also have like our stage builds that we have tested. We know where their power levels are, where they tend to fail at, and where you start needing to go to the next level. And yeah, we're a small company and we want to keep it that way. So I would call us more of an artisan
okay.
style. So I do all the builds, I do all the machining, I deal with all the customers. I have one other apprentice, and we are not a mass production shop. We do about 150 motors a year, and that's really all we want to do.
Sure.
Once you get beyond that, we feel like you start losing some of that quality control that happens when you start mass producing things. You start losing that level of ownership in the builds. So yeah, I mean we that's what we really specialize in is owning the builds. So
And when you say machining, worth mentioning that you do a lot of that or most of it in-house. So it's not just the assembly, but you're doing a lot of the machine work in-house also.
that's right. We do. So everything's done in house. I mean, obviously we don't make our own pistons, but we partner with, like CP who does pistons here stateside. We buy cranks, from Subaru, but all of the block machining is done in house. So we'll do all the
Okay.
CNC milling. We do all of the honing in house, the decking in house. We do all the head work in house, all the porting in house. Like we do everything that we can control reasonably in-house, so we can control those tolerances and control the quality.
Okay. Well, let's talk about racing here for a second because definitely seen you guys out there at Super Lap Battle at Coda a few times, and so I want to hear about that. But I also want to ask you about on your website you mentioned that you've supplied engines to some of the guys that have done World Time Attack as well. So I want to kind of hear about that story if you can.
Yeah, so yeah, Global Time Attack, Super Lap Battle. So we started going there, that was 2018, 17, 18. And yeah, we've been running the 2 minute 20 second, 2 minute 30 second time range for that. And the car was 3,600 pounds, it was super heavy. We were making good power. And as we've progressed through the years, this car has been raced for 10 years.
Hmm.
So our personal shop car. And that car is now twisted and mangled to the point that all the seam welds and all the rivets and all the glue that held the chassis together is all coming apart. It's
Oh
10
man.
years of hard racing on the Subaru. So and we did a lot of Coda, which is 20 corners. It's very fast paced. It's 170 miles an hour on the back straight into a very tight second gear corner, left hander. So it's very, very, very hard on the card. I think it's probably the hardest track in North America on a Subaru specifically,
Hmm.
just because you beat the snot out of it. So it was our test bed for a lot of our engine program. If it can survive there, it can pretty much survive anywhere. That's was our mode of
Sure.
thinking. So that car was really the test bed for our staged blocks. So we always ran our staged motors at each of those races. This coming year and really next year, we're going to have a specific race engine with a really high rod to stroke ratio that's going to rev to 10,000 plus RPM. It's going to make crazy power and be sequential, but
Hmm.
we've always tried to test our engine program there at Superlap. And so we've always been stuck at the 220 range. And I think we're going to push really into the 210s coming up here in the next couple of years. That's really the goal.
Wow.
So yeah, as far as World Time Attack, we worked with a guy named Iden who's got a big following on IWSTI. He's been there forever. It's Project T something, so you
Hmm.
can find him if you know what I'm talking about. He's a really good guy. He's been a really big supporter of us from the very beginning. From when we started the company, we worked with Iden and sent him some engines. We both kind of came out of buying engines from the same builder that did some things that was not good for the
Ideal.
community. Yeah, yeah. I mean, talking about like putting concrete in the water jackets and calling it a closed deck. It was
Oh no.
oh yeah, yeah. It
Oh
was
boy.
yeah, a bit of a mess. That's really what kicked off P2P.
Okay.
And working with Iden. And so we've been sending him, we've done 3 engines with him over almost 10 years. And so just a refresh and send it back and forth. It's expensive, obviously, to send things to Australia.
Yeah.
And he's done exceptionally well. He should have won his class. I think he got bumped down to third or something I can't remember, a few years ago. But he's getting his car ready. He's working with God at Rex down there. We've worked with those guys. They're really awesome. Highly recommend it if you're in Australia listening to this. Go hit up GIR. They're good people. But yeah, that's really the extent of those two. Those
So
two
I
races.
guess so suffice it to say, you guys you've tried a lot of stuff. You've put these engines in cars on racetracks. You've seen how they perform and you've made whatever changes you need to make and you're starting to kind of you've got it a formula now. You've got it all laid out.
That's right. Yeah. And so we've tried different manufacturers for pistons. We've tried different manufacturers for rods, the bearings, the clearances. There's so many variables that you can put into these engines to see what works and what doesn't. There's old school methods of, hey, run extra clearance, oil passages, all these extra clearance in the bearings because that's what we did for racing back in the
Hmm.
day for naturally aspirated engines. It does not work for Subarus. Just increases your bearing wear because you're
Hmm.
point loading the bearing. But yeah, we learned a lot those early days, and before we ever started selling to anyone, we never really had any failures. We just always would take them apart and see increased wear when we did this, or this piston is letting too much blow by with this ring in gap, like all these different things that we were learning over the years. So
Okay.
the racing program really fueled the stage blocks that we sell now.
Gotcha. Is there one or two things that you do that you don't see anybody else doing or don't generally see anybody else doing that you feel like this is something that like you see the value in it, so every one of your Sherplocks is going to have it, but it's maybe not something that's commonly done outside of you.
Yeah. So the biggest one is that ownership aspect, right? So like when you send a block in, you have one person touch it.
Mm,
So you have the same person disassembling it, machining it, assembling it. That to me, that adds a lot of value because you're not having the quality misses that you do with, let's say, 6 or 7 people touching it. There's one guy that hones, there's one guy that machines, there's one guy that decks, there's one guy that assembles. And there's anytime you have turnover like that, there's always things that are missed.
sure.
So our goal is the customer to not ever have a failure, right? Because
Okay.
that's expensive for them to pull it out. It's expensive for them to deal with. We don't ever want them to have to deal with that. And so that to me, that's one of our biggest things that we do differently. A lot of people out there will mass produce. The other thing is pin mains. So
Oh,
early on, we started seeing additional wear in the rod bearings. We really couldn't figure out why we had great oil pressure until we started getting high up in the RPM, the high power range. Put two and two together, and we now pin all of the mains on all of our blocks. The webbing in between will start to flex, under the increased
okay.
power load. So we started seeing wear on the outside of the bearings for the mains, and we said, "What is that? Is the crank bending?" No, it's not the crank. It's actually the webbing taking the load and bending slightly. And you're talking a few tenths, but that's a huge difference in your clearancing. So what that does is it reduces your oil pressure to your rods, and then you have additional rod bearing wear. And
Interesting.
so we started pinning those. We use a really long pin in between, so it keeps them from sliding, so it doesn't slide, but it also doesn't bend. And so
Okay.
that long pin is key. We also do that in the FAs. Subaru realized, I think, in the FAs that, hey, we've got to pin the mains, they're moving. It's same problem that they're having in the EJs, but so they put a little tiny dowel in there. It's maybe 3/8 of an inch long.
Oh, wow.
So we yanked those out. We put a really long one in there for the similar reasons. But yeah, and then we actually will remachine the mains, perfectly where they're supposed to be. If you understand GD&T, the bell housing of the block is the most important plane, and your
Okay.
crank needs to be perfectly perpendicular to that so that you don't get any side loading from clutch or transmission misalignment or anything like that. You want your crank to be perfectly perpendicular to that. So when we machine it perfectly perpendicular to that, right between where the head gasket surface is and a certain distance up from the oil pan. So it's like all exactly where it should be.
Okay.
And when you do that, if you look at a Subaru factory block and you measure a brand new one, you could have as much variance as half a thou, so 5/10,000ths of an inch between mains. And when
Okay.
we do it, it's 1/10,000. So it's much more accurate.
1/10,000th variance across the mains.
Across from main 1 through 5,
Okay.
you might have a variance of 1/10,000th of an inch, and really I think it's due to temperature on the tool as you're holding it going down, just
Sure.
changing.
Wow. All right. I want to back up to make sure that I understand correctly the start of this, which is to say, so you saw rod bearing issues, which is very commonly discussed in Subarus, and you traced it back to potentially main bearing issues,
Yes,
basically. And so that's why you pin all of the mains. So like every single sharp block that you make, you're pinning the mains.
that's right. Yeah.
Okay.
So I mean, if we're doing like a 300 horsepower block, it's anything that's getting increased power, right? So like our
Okay.
stage 1 and up will get a pin main. And the reason why is for what we talked about, but it's twofold. So it keeps it from flexing, but it also allows us to remachine those mains to be exactly accurate. And so instead of
Okay.
oil pressure dumping out of the mains, not getting to the rods, because that's how it feeds. It feeds from the oil
Gotcha.
pump
Okay.
to the mains and then to the rods. Rods number 4 is the last one to get it. So if you're having mains issues, your rod number 4 is usually going to be the one that fails. So,
Okay.
or, there's a split between 2 and 3 as well, but you typically will see number 4 fail.
Okay. Interesting. And so, yeah, so pinning the mains, then you have to basically do a line bore for the mains, and then that gives you the ability to kind of exactly set those main tolerances too. So there's two really big benefits in you pinning those mains for those reasons.
That's right.
Okay. And obviously that works. Is there anything else that you do, or
Yeah.
was that kind of like the main, those are the big ones? I mean, it seems kind of like a big one.
So like the biggest thing is, yeah, so we talked about the ownership, but on the honing side, so you have a certain crosshatch you need to run. We measure that. We can prove, when we do all of our recording and measurements, we take pictures. There's an app that we use that records everything. We use a microscope. It looks at, what your surface roughness is. It looks at what your angle is, and verifies that it's to the ring specification for the piston. So, I don't know of anyone else that really does that except one other company. And they're stellar company. So, it's not like an old school, machinist that's just running old stones down and, maybe setting the angle. The deck is obviously decked a different way. We do it based on where the mains are, put the cases together and deck the mains. Deck the decking for the head gasket. There's just, again, the parts that we put in as well. They're not overseas parts. A lot of them are made here in the US, like Cali's. We'll buy everything Cali's that we can. It's all supposedly forged here in the States. We'll run a CP piston as much as we can because we know that they're here in the States. There's a lot of rebranded pistons that are out there that are forged overseas and then rebranded with a name here in the States and sold as a great piston. But I mean, the cost difference is like $650 for a US made set versus $180 for one that's made overseas. So there's a lot of companies doing that, and we just don't agree with it. We feel like you get a much better product when you get these consistently good forged pieces.
When you're talking about building an engine to this extent, I mean, if you're putting in that much care into just the case halves, I mean, you definitely want to make sure that every part that's going into the case is as top notch as it could be. I'm guessing too that as you're doing the assembly, there's a lot of measuring and checking of all of these components, even if it's a company that you work with a lot, that every box is a new box, and so you're taking the parts out and inspecting them every single time.
That's right. Yeah. So a lot of companies will take a box of rods and they'll have one measure 4/10 over, one measure 2/10 over, 1/10,000th less, and they'll set them on the shelf where those are, right? And they'll say, oh, my crank is this, my crank is that. And really, we don't do that. We set the rods all the same, and we'll buy a bulk 100 cranks at a time, measure all of them, and probably send 80 of them back. Because we want our cranks consistent. We want our rod big ends consistent. We want our rods to weigh the same. It's a lot of time involved in measuring and cleaning and doing all that. That's not seen, you don't make money on that. It's just quality.
Right. The end result is better for it, but it's something where like you just don't see that that often because it is so time intensive on the front end just to load in the parts so you can actually build the engines.
That's right.
Okay. Well, so because you talked about kind of having, walking through a build with a customer. So let's say I'm a customer and I come to you and I want to make maybe either 400, 500, or 600 horsepower. What are some of between some of these ranges? Because I would say that those are the most common power targets for Subaru people these days with an EJ engine. What are some of the key differences in that range where like if I, like where you'd recommend one block versus another, or maybe, one option versus another for something in that range?
Sure. I think power goal is one piece of it. So what are you going to use the engine for, right? It's really the next question.
Okay.
500 horsepower on the street is 350 horsepower on the track is usually what I tell people. So,
okay.
And the reason why is because you're running 20, 30 minutes, full on, flat out, that it just is, it's seeing additional wear, it's seeing additional loading that, a street engine isn't seeing at 10, 15, 20-second pulls. So really that's the next question. And then the question after that is, are you really going to run it on the track 100% of the time? Because a lot of people say, I want a track engine. And what that entails is additional maintenance. Ring end gaps need to be bigger so you can consume more oil. Are you aware of those things? So that's usually how the conversation starts. And then for somebody that wants just a street engine that they want to track every now and then, which is probably 95% of the people that are out there.
Right.
Up to 500 horsepower, I would just go with the stage one. Mainly because our stage one is just a rod and piston block. It's good to 500 horsepower. and it's really good to about 550, but we try not to push them too far. And the failures are really going to be at the water jacket to bore. So there's
Okay.
a location where you put the case bolts in at this is for an EJ.
Yeah, where it's got the little scallop.
Yep, that's where they fail.
Yep.
And so if you're on the track, you want to detune quite a bit, make sure EGTs aren't super high. Otherwise, you'll blow out, you'll crack the cylinder wall there. So for people that want to run 500 horsepower on the track, I would say go to our stage 2 and get a closed deck. It's basically a stage 1. It's just adding a closed deck to it. And it gives you that peace of mind that you're not going to blow out the cylinder wall. And then from there, you can go to stage 3, which is up to about 650 horsepower. All you're really doing is changing the rod, because to get 650, you're going to increase torque. We need to add a thicker rod. And then we're going to increase the head stud size to 1/2-inch head stud, which is a lot beefier. We don't really see failures on 1/2-inch head studs, even to 40, 50 pounds of boost. So, but we do see them on the ARP 2000, 625, 11 mil, stock size head stud. Anything over 500 horsepower, 28 PSI is going to start stretching those.
So I want to go back to an important point that you made, that there's a big difference between making a certain power number for the street and a certain power number for the track. Can you elaborate a little bit more on some of the different stresses that you see on engines when you're driving at the track that you just kind of never would see on the street, and why those different stresses really necessitate kind of building the engine with track use in mind versus street use?
Yeah, it's really going to come down to heat, right? So heat and tunability. So if you're running an access port, let's say, which is what I did for 10 plus years in the track, you're running an access port and you're running on the track, your tunability at the very top end, when things start getting very hot and very heat soaked, your intake air temperature starts changing quite a bit. Basically stoichiometry inside the engine changes more than what you're tuned for usually. That's when you start seeing knock, detonation. You start seeing some fuel starvation issues, and really you don't see that on the street nearly as much as you do on the track. So I always say overbuild for the track, because it can then take that abuse. You're going to blow out a cylinder wall going on the track at over 350. Really, if you're running a stage 1 or a stock block, it's just it's just a matter of time. And it's the heat soaking, and then it's the tunability afterwards.
Okay. Yeah. The heat load is something that you have to factor in, because when you're on the track, the time that you can spend at wide open throttle, the time that you spend making, like if your car makes 350 horsepower, the time that you're spending at 350 horsepower is a lot.
Yep.
Whereas if you're on the street, the time that you spend with the engine making that power is much, much less, because usually you have to either shift or just, like, that's it. You're now at speed. You can't really just stay in the throttle for 7-10 seconds at a time, whereas like that's kind of what you're doing all the time at the track.
Yeah, I mean, that's a really good point. Like on the street, let's say you're pulling from 3rd, 4th gear and you're at 6,000 RPM, you're living there for 5, 6, 7 seconds.
Yeah.
And at the track, you are 20 minutes above 6,000 RPM usually,
Right.
Just straight if you're actually racing it.
Yeah.
And that's a lot of load on that engine that isn't normally seen daily driving.
Yeah, it's something, I think people want a car where it can just do everything, but and some cars are so detuned that you can get away with that more, like driving on the street. Like you drive it to the track, you track it for a day, you drive it home and change the oil and everything's fine. But with these Subaru engines, they're pushed a little bit harder, especially once you start making more power, and you just have to consider things like heat load and that sort of thing, because you're just the difference in heat that an EJ engine sees between like driving to the track and then driving at the track is just massively different.
Oh yeah, no, it's a totally different tune for a street than it is for a track as well. Like
Yeah.
I won't speak to, I'm not a tuner, but I can tell you the tuning time it takes for a track tune versus a street tune is significantly different.
Yeah. And then, so you mentioned the difference between, stage 1 and stage 2 being the closed deck. Can you just dive a little bit more into where the closed deck comes in and why? Like what does putting a closed deck insert in a factory EJ block do, and what is the significance of it?
So basically, a closed deck is creating a compression ring around the cylinder. So the piston, when it comes to TDC, it's then getting its fuel burn and it's creating its power for the top half inch of the bore. So if you take a bore, you look at the top half inch, that's where all the stress is on the bore. And so what can happen on the bore, and as we see this in the 2 liters and the 2.5s that are unsupported, is the bore will actually move around slightly
Okay.
and you'll start having head gasket failures. The 257, we added their Subaru added the little tacks, that hold the bore
Yeah.
in place to avoid that. What we do is we actually machine some of that out, and we put an insert that's a press fit insert. It's got an interference fit. And so what it does is it kind of creates this compression ring. And I would caution some people to watch out. There's a lot of closed decks that are out there now. There's some that are out there that are a full ring, and if the material is different, and so it'll grow differently, and so your bores will actually grow differently than what that ring is allowing it to, and you can actually cause cracking or additional wear on the piston. But yeah, so you're just creating a ring, and it takes that explosion, and that's inside the cylinder, and it distributes the stress evenly around the engine versus just hitting a thin wall portion where they cut that scallop out for the case bolt. So
Okay.
it's basically a fatigue question, like how many times can you take a load, and how many times can that little webbing take it before it starts cracking, and then it'll eventually crack and blow out.
Okay.
That's why we
And
add that inside.
sure. So it seems like with a closed deck, maybe there's a consideration of strength versus cooling, because where the closed deck is going is where the coolant flows from the short block into the cylinder head. So are there considerations with that as well, like just from a cooling standpoint?
Absolutely, yeah. So basically, you need to be able to take that heat away from the cylinder wall, put it into the water, right, for the water jacket or the coolant, and then send it to the radiator. So you basically need to get it out of there. So on the underside of our closed deck, we put a channel. So it actually helps increase the surface area, therefore getting more heat load out. And then on the top side, we create a channel. And what that does is it allows for you to run whatever head gasket you want. It's what we call a communication channel. So if you look at the different head gaskets between like an OEM, a Tomei, all these different head gaskets that are out there, they have the little ports are different.
Yep.
Right, because it didn't matter where they put them, because you didn't have a closed deck with Subarus. You just had open jackets there.
Right.
And so some manufacturers will match those to a specific head gasket. What we do is we actually make that channel so that you can communicate with whatever head gasket you want. So we run a lot of Tomei, we run a lot of fire ring stuff. And so there's different, and we need to be able to use all these different ones. And so it's really important for us. So we haven't seen on like race car stuff and track stuff, we haven't seen any additional heat load on the car, just because there's so much cooling, and if your airflow is right, it's not a problem. On the street stuff, when you're still running a top mount intercooler and those types of things, we haven't seen it specific, but we recommend people to increase their efficiency in cooling, run an increased radiator, and we've never seen an issue with those blow out or have issues with cooling long term.
Okay. Perfect. You mentioned like head gaskets and firings and that sort of thing, and then like you'd also mentioned, I think it's with your stage 3 block, you move to a 14 millimeter fastener versus this like an 11 millimeter fastener. What other things, like where does a firing come in? Where do you need to, or what are some of the considerations for moving from one type of fastener to a different type or to a different size, and then like a firing? How do you make those decisions?
Yeah, so it's really gonna be boost. How much boost are you going to run? So on the stage 3, we actually run a half-inch head stud, and the reason we don't step it directly from an 11 to a 14 mil is because the 14 mil puts so much stress on the head that you can eventually crack your head.
Okay.
So we save it for when you really have to run it. So the half-inch head stud will torque. It's a smaller diameter, so it'll only torque to 125 foot-pounds. It's less load. We've never seen a head crack with a half-inch. Under race conditions, we have seen the 14 mil with big ports. It'll start cracking in the port and water jacket just because there's so much stress there. So we limit those to the higher end, stage 5 plus. But we haven't seen like half-inch head studs. If they're tuned correctly, we can get up to 45 psi boost,
Wow.
which is up to 750 horsepower ish at the wheels. And then and that's with just a regular MLS head gasket. That's no O-ring or fire ring or anything.
Okay.
Uh, Anything over that, you want to run giant turbos and make 60 pounds of boost, which we've done. We go to a fire ring of 14 mil.
Okay.
Just it's so go ahead.
So boost pressure, like it's not a power target necessarily. It's really how much boost pressure, how much pressure is going to be in the cylinder.
That's
That's
right.
that's that's your main consideration for going with something other than just a standard MLS head gasket.
Yeah, I mean, ultimately it's cylinder pressure, right? So
Yep.
you're generally going to be making that later in the RPM range with Subaru blocks like 2.5 liters. There are times, like especially with the race car stuff, like when we want to start pushing stroke and start getting that as soon as possible, where that's when you start needing to run 14 mils sooner.
Okay.
But it's going to be related to how much torque you are putting down at a certain RPM range. That's when we'll start pushing that
Gotcha.
14 mil versus half inch.
Okay. One other question just on the EJs about crankshafts. Because you mentioned, oh, sorry. Oh,
I think I lost you there for a second.
no worries. So sorry, I was going to ask about crankshafts. So you mentioned that it sounds like you use stock crankshafts. You measure them and you pick kind of like the best of the bunch before you assemble them. When and when and if do you go to an aftermarket crankshaft that maybe is a billet piece, something that is cross drilled? When do you see need for that, or do you go to that point?
Yeah, so we definitely go to that point, stage five. The newer crankshafts from Subaru are just fantastic. We've seen
Hmm.
them go up to 900 horsepower, like without braking. Again, that has to do with where you're making the torque and the RPM band. But we'll start running a billet at the very top when we want to run over 1,000 horsepower, and the cost difference, and really that's what it comes down to, is a cost game. On if you're running that much power over 1,000, you're going to be looking at refreshes every couple of years at most, just because you're racing so hard on those blocks. And so then you're looking at, if you've got some wear on your crankshaft, it's a $1,500 replacement versus a $400 replacement.
Right.
So that's really the discussion on like the longevity. If you want to keep doing this, what does that cost look like? And we like to let the customers know ahead of time, like if you're running a billet crankshaft, it's very expensive, and if there's any issues, it's very expensive to replace.
Sure. Do you see Are there benefits to just the cross drilling in and of itself? Like, does that help to solve any issues, or because the
I
stock one works well enough is it's just not worth the expense?
Okay. I think my video is just causing too much bandwidth out here in the boonies.
Okay. All right, no problem. Well, okay. So the question I asked was cross drill cranks. Is there a benefit to that, or like do you see, or is it just because it only
Yeah.
comes on the billet crankshafts? Is it just something where it just doesn't make sense for most builds because the stock cranks are good enough?
I think cross drilling was a band-aid for the mains not being right.
Mm,
I haven't seen. So we ran on this last build that we did in the race car. We ran our stage 3.5 block, and we ran it for 3 years in there, and we beat the snot out of it. You can look at all of our Instagram, like any of the videos we posted. That was on the same motor. We never changed it out. And when we took it apart, there's also that video of where we took it apart. What it all looked like. The wear looked perfect. It looked like it was, maybe had 100 miles on it. It was amazing how good that engine looked.
mm,
And so that's how I can confidently say like the crankshafts as they are from Subaru without the cross drilling. Now, obviously, 75 mil has the cross drilling, but the 79 mil crankshafts, they're fantastic. I haven't
mm.
seen any benefit to go into a billet except for power.
Okay. Okay. Um, I want to ask you about your race car, but before we do that, I want to touch on the FA engines because a
Sure.
lot of engine builders uh, right now that like the EJs, they've been around forever. It's pretty much a known quantity at this point. Um, but there's not as much energy that most people are putting into the FA series. but you guys have done that. You guys have really started playing around with the FA blocks.
Yeah.
And so I want you to just talk about kind of one, what some of the key differences are between the EJs and the FAs. But then two, what your FA builds look like, and are there different considerations, or is it kind of largely the same?
It's largely the same, I would say, because we basically just take a block and redo everything.
Okay.
I mean, at the end of the day, we're still pulling the pins, remachining them. We're still remachining the mains. We're still honing everything out. So the biggest difference really is the bore size, and how it relates. So like you're not going to see as much of a pressure in load on the head gasket with the 86 and a half mil versus the 99.75s. Like you just have a bigger area, therefore it's trying to push the head off with more force than on the smaller bore size. And so we will get away with a lot more in terms of being able to run a stock size head stud for longer than we would with an EJ. But
Okay.
the only other thing I really don't like on the FAs over the years has been the chains, the timing chains. So we built an engine for a guy that was running a bunch of SCCA stuff. He was like national champ. He was awesome. And he kept having issues with engines coming apart. And so we tried to help him, and he went then to a different, more power, made like 350 horsepower on an FA20, and it was supercharged, like 8 PSI boost, and was running a sequential, and it was full race car. And he would go out and he would break a timing chain on shift. And when that happens, obviously it's a total loss on the motor almost. You might save the bottom end or something, but it's bad. And so we went through that, and there was no off the shelf solution. If we could figure out a way to like double up on the timing chains, I think that would help it. But for any kind of road coursing, with sequential kind of the top end race stuff, I still prefer the EJ just because that timing belt is more forgiving. We played with tuning on how to soften that cut during shifts, and it just didn't help. But other than that, I mean, like the FAs make power easier, just because of that direct injection, and they flow a little better. But as far as they all have their own little issues, and the EJs are really a known quantity at the very top end, and if you're asking me which one I prefer in the race car, it's still the EJ right now.
Sure. Yeah, the FAs, especially the FA24 seems to have a lot of potential in it. And like I said, it's so much easier to make power, at least at that entry level point. To get to that 300, 350, even 400 horsepower seems to be way easier with that FA24 than it ever was with the EJ. But there's not as many cars out there making 500, 600, 700 horsepower, so that the path is not as defined.
Right. In the future, in the future, I think we're going to take that FA24 and start mating it into the race car, just because, once we solve some of the timing chain issues, because we're going sequential as well. It really has to do with the transmission, and then, the wastegate control and all that type of deal. So once the aftermarket starts catching up to that, I think you'll start seeing a lot more FAs push. We have been contacted. I mean, we have an FA24 closed deck built block that we sell. It's not really advertised just because we don't have enough seat time on it, so to speak. But
sure,
we've got one out there that's making about 780 horsepower right now. It's again mated to a 6-speed, but and running a custom turbo kit and all that. But it's in Motec, so that's the route we're having to go to make that power. So it just doesn't make sense for a lot of customers to do that yet.
Sure, but the more and more cars that are out there with them that people are playing with, I mean, I'm sure we'll figure it all out. It's just going to take a little bit of time.
That's right.
Yes. All right. So you mentioned the race car a couple of times. You've kind of mentioned to me some of the crazy stuff that you have in mind for this race car. Let's talk about this race car. So this is the same car that you said you've been running for about 10 years.
Yep.
And now you're kind of doing, like, you're throwing the kitchen sink at it, right?
Yeah, this is as much as I can think to do to it. So I'll start from the beginning. We brought it down there to make brought it down to our fab guy. His name's Damien. He's old Le Mans. He was an old Le Mans tech back in the Toyota, worked for Toyota. has a lot of knowledge on how to build race cars.
Okay.
He's forgotten more than I know about it, so he's fantastic.
Good place to start.
So yeah, and he's sort of like me. He's an artist by heart. He doesn't want a lot of mass production stuff. So people who know him know him.
Okay.
But anyway, we brought it down to him and said, "Hey, I just want to make the front clip removable. The whole front end is moving around on us. We can't figure out why."
Hmm.
And he pulled everything apart and looked at it, and he's like, "Yeah, your front frame rail on the passenger side is an inch and 7/8 higher than on your driver's side. So you must be going counterclockwise quite a bit." I was like, "Yeah, that makes a
Oh
lot of
man.
sense." So he started investigating further, and yeah, on the back, on the rear of the car, it was doing the same thing. We started looking at the welds on the pickup points for the suspension. All of those are starting to break, and it just became a decision on, what do we do? Do we go get a new car and just keep trying to break into the teens, break down into the 20s, Coda, or do we just let's do this right?
Hmm.
So the decision was made to cut out the cage, cut out the floor. Literally everything's getting done to it. The only thing right now remaining on the car is the A pillar, B pillar, C pillar, and the frame rails.
Whoa.
The firewall is mostly still there as well, but everything else is getting changed to carbon fiber, to some sheet. We're doing the engine. I'll start the engine as well. So the engine is going to be an EJ20.
Okay.
So I wanted to prove out the EJ20X. That's a kind of an engine that's becoming more available out here in the States.
Hmm.
And so the EJ20X is different than the EJ20 or the 205. Um,
Okay.
and so we're starting to buy some of those up and build them up. So what we want to do is run a really high rod to stroke ratio on it. We're running like a 1.91 to 1. And for comparison, stock EJ is like 1.64.
Okay.
And so really high rod to stroke ratio. And the reason that's important is revs. So we're going to be able to rev. It's going to live about 7,500 to 10,500 RPM.
Whoa.
Yeah, we're going to make in the neighborhood of 700 to 800 horsepower, with the ability to throw on a little extra boost and maybe make it into 900 if we really need to for a hot lap.
Yowza.
The whole turbo system. Oh, can you still hear me?
Yep. Yep. I can hear you.
Okay. Yeah, it's starting to act up again.
Oh boy.
Um, I'm sorry, man. This
That's
internet
okay.
is terrible here. But yeah, so the turbo system is going to be custom. We're going to do a water to water intercooler. Uh, there you go. Seems better now.
Okay.
And then we'll run a sequential, and we'll have a bunch of the diffs will be tuned correctly. The suspension is going to be a three-way. We're going to be running LVDTs on it with a full standalone. A ton of downforce, like aero. It's the tire is a 335. We're going to run a 40 tread wear race tire, soft compound.
Wow.
It's going to weigh about 2,500 pounds, and it's going to make about between 7 and 900.
Wow.
Affiliate.
So the
So
target for weight is 2,500 pounds. Power target is 800 to 900 horsepower, and then lots of downforce and big sticky tires and all that jazz.
yeah, and the biggest mod that we're going to do is probably a better driver.
Oh boy. Okay. Or yeah, the driver mod. It's always a good thing.
Yeah. So we're still looking for who we want to do put in the seat. I mean, I'm obviously going to try and drive it, but I don't think I'll be able to get the most out of it. I'm not nearly experienced enough, but we want to see that engine and that car go and do some really cool things. And tired of seeing these Corvettes come and dominate. So
For
it's
sure.
it's
For
time.
sure. Nice. For progress on this build, is your Instagram page the best place for people to follow, or is there another
Yeah.
place? Yeah.
Yeah, let's give you the best. We're doing some things that nobody's done before yet. We don't want to copy it until it's out there. So we've got some of that we won't be. It won't be super up to date, but it'll be within a month or two of
Sure.
where we are. But yeah, like and the car's in Houston. I'm up in Dallas, so getting those updates are. Yeah, I've got to drive down there and go look at everything and do some videos. And I'm actually doing that
Sure.
on Saturday, so tomorrow.
Oh, cool. What
Yeah.
kind of what kind of a rough timeline do you have in mind for where the car is going to be together to the point where you're going to be, shaking it down or possibly, pie in the sky first event?
So the goal for the fab is June. So we want all the
Oh,
fab done by June. the cage is finished, and we've got some other things to do like flooring and whatnot. But Damien's working on it extremely hard. I know he is every night. But you know how those things go. So
Yeah. It's a labor of
goal is,
love. Takes time.
yeah, that's right. Goal is June. And then we've got a lot of tuning to tune out of the car. Not just the engine, but everything else. So everything else is ready. We've got all the parts. So it's basically just put it together. We expect it sometime in, I'm going to realistically guess, October, November,
Okay.
before we're really ready to get out there and start putting some times down. And you know that bit us last year, in 2023 at Super Lap, is we had gone December of 2022
Mm.
and had put down a 220 with some change on it, and we actually ran a really quick lap out there when we were testing, and then we get out there for 2023, and apparently everything was broken. Like
Oh
everything
no.
was just falling apart. Like all the pedals were coming apart. Like on the accelerator pedal, which is
Yeah.
the silliest little thing. But running an OE accelerator pedal, it started throwing a code, which would, put it into limp mode, like 1 or 2 cylinder limp mode. It was horrible. Um, and then, yeah, we had, again, all the car was moving around on us so much, like you go into braking, turn 9 or turn 10, and the the steering wheel would shake because the front ball joints were coming loose and wallering out, the taper that's in there.
Oh man.
And really unsafe stuff. And we just, that helped fuel that decision to, let's just do it right. We're going to take our time. There's no
Yeah.
rush. We need to make this right, and let's get out there and actually do some good times.
Nice. Yeah, race cars are funny because they want all of your attention, and they have ways of acting up if they don't get it.
Yes.
Yeah, they all have personalities like that. It just seems to be part and parcel of having and running a race car, it seems.
That's right.
Yeah. Well, very cool. Well, Ryan, since the internet connection is a little bit spotty, I think we'll wrap it up here. Good a place as any. Again, P2P Engineer, or sorry, P2P Racing. You're on Instagram. We now, Flatirons Tuning now offers P2P Racing Sharplux on our site as well. So, you can feel free to reach out to us if you got any questions. Reach out to Ryan. Um, yeah, all good stuff. And thanks for talking through your process with us. It's great. I think it just helps people to understand more about what goes into these Sharpluxers. It's not as simple as just putting simple parts together. There's more to it than that.
That's right. Yeah. And, there's so many people out there that say that Subaru engines aren't reliable. And, I have such an issue with that. Like if you build them right, they're just as reliable as anything else. I mean,
Yeah.
we have just as many requests for LSX blocks and LS motors to get built as we do EJs these days. I mean,
It's always
it's a motor at
it's
the end of
always
the day.
something. And
Yep.
yeah, motors are like race cars. If you ignore them, uh, they have a way of acting up and getting your attention sometimes.
That's
So
right.
yeah.
That's right.
Well, brilliant. Well, thanks again, Ryan, for all your time, and thanks everybody for your support as always. And until next time, stay tuned with Flatirons Tuning. Thanks everyone for tuning in to the Flatirons Syndicate Motorsports Podcast. Once again, we'd like to let you know that your support is what makes this show possible. Be sure to check out our online store at flatirons.com for any of your aftermarket or OEM Subaru parts needs. And as always, stay tuned with Flatirons Tuning.